In this video, I am going to discuss about casting design and defects. A proper casting design has to be made for producing a high dimensional accuracy casted product. So if you are not maintaining any design standards, then finally the casting will have several defects. So those things we are going to discuss in this slides. So initially we are going to see about the casting design. So the parting line. So you know there is a parting line between the cope and drag. So the parting line should be always as a flat plane. So you can see the correct method of how to place the parting line in the first picture. And when you take or consider the pattern, always the pattern should have a draft or taper angle, so that it will be very easy for us to remove from the mold. Otherwise, if you don't provide any draft or taper angle, it may affect the surface of the molding core. So this unnecessarily it will create a problem when you pour the molten material into that. So the same type of defect will be once again reflected in your casted component. So always in pattern design you have to follow the draft or taper angle for easy removal. And where you have to particularly place your riser. So in left picture you can see that the riser should be always placed near to the heavier section, and it should not be placed at the least section. This will avoid the casting defects. And when you consider the sharp corners, these sharp corners will produce hot spots and high stress. So wherever possible we have to avoid the sharp corners. So you can see the better product where we have avoided the sharp corners by providing fillet radius in both the sharp edges. So this is the right way for producing the casted component. So in turns, this has to be done during the design of pattern itself. And the abrupt change in sections, it should be avoided. So you can see the left picture where there is a sudden change in the dimensions. So it has to be avoided. The probable thing will be 2:1. So if you consider 100 mm as your initial dia, and if it has to be reduced, at the maximum it can be reduced to 50 mm. That is the proportion which it has to be maintained. Otherwise you can just give a small slope to avoid the abrupt change. When you consider the interior walls, it should not be very thin, because it may face some cracks or even breakage of those interior walls. So normally the interior walls should be made or designed thicker. And then we have to add additional material wherever you have higher stress. So in the left picture you can see that wherever the region you have a higher stress, those can be avoided by proper design of pattern. And the next one is the residual stress. So you know that the imbalanced design of your pattern may produce higher residual stress. So always the thickness, and it should be maintained as a uniform one, so that then it will be producing a balanced size. So when you consider the three pictures in the right side, you can see the first picture is evenly distributed, all it is balanced in size. But the other two pictures, it's not in balance, because the spoke is either smaller when you compare to the outer rim. So always it should have a balanced size to reduce the residual stress. And we have to use thin wall design to avoid dishing. So wherever possible you can also put a holes. So that is the way you can avoid the casting defects. And the last one is you can always use odd number of spokes. So either you can use 3, 5, 7 and so on. You should not use even number of spokes as shown in the figure. This will also avoid the casting defects. So these are all the possible ways of avoiding the casting defects. But if this design of casting is not probably maintained, then you will have certain defects. So there are three different types of defects which you will see after the casting is been made. The first type of defect is called as shape defects, where the first picture shows you the flash. Flash is nothing but the irregular fins which are placed around the part. And the next is your mismatch, where it will happen when you use cope and cope and drag shift. So whenever you have a mismatch between the pattern which you place in your cope and drag, this type of mismatch will happen in your casting. And the next one is core shift, where due to the placement of core, if it is not proper for making a hole, then this damage you can see in your casted component. And finally distortion. So the shapes like I, V, M, L will have distortion. So proper allowances like distortion and camber allowance has to be made while designing. So if that is not properly maintained, then you will get these types of shapes defects. And then comes your filling defects, where the first one is your blowholes, which is entrapment of air. So proper provision which should be given to make the air to escape to the atmosphere. And the next one is cold shut, where it is made due to incomplete fusion of molten metal. And the third one is your porosity, where it will also be formed due to the entrapment of gases which comes out of your liquid metal. So a small pin sized holes will be seen on the surface, which is called as the porosity. And finally it is inclusions, where the mixture of sand also will be just a part of your casting. So that should be avoided. So these are called as inclusions, and these types comes under the category of filling defects. And finally it is solidification defects. The first one is hot tear, where the crack formation will be happening due to the contraction of your casting. The second is your shrinkage, which happens due to the lack of metal. So if you are not considering the shrinkage allowance, then these types of defects will happen. And the last one is your sink mark, where it has been formed due to the volumetric contraction in the thicker surface. So there is a particular difference between shrinkage and sink mark. So sink mark happens only due to the volumetric contraction in the very thick surface, which you can see in the figure. So these are all the possible defects which you will get in casting when the casting design is not proper. Thank you.